Hello, and thanks for joining today's TI Technology webinar hosted by Texas Instruments. Tonight we're going to take a look at some foundations for success in statistics and probability, a focus series of TI Nspire lessons and building concepts. Thanks so much for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. I'm excited to introduce our two panelists tonight, Jennifer Wilson and Michelle Reinhardt. Jennifer is in her 23rd year of teaching mathematics at Northwest Rankin High School, where she uses TI Nspire CAS and the TI Nspire Navigator system every day, both to teach her students and learn from them. Jennifer received the Presidential Award for Excellence in Mathematics and Science Teaching in 2011, and she received the T-Cube Leadership Award in 2013. She enjoys writing mathematics curricula, using technology, and working with educators to incorporate good questioning techniques, engaging problems, and formative assessment in their classrooms. Thanks for being with us, Jennifer.
I'm glad to be here, and I wanted to jump in real quick. We are excited to have you tonight and wondered if you might introduce yourself in the chat window as we're getting started and tell us what your favorite animal is. We're going to use some of that data in just a few minutes. Thanks.
Thanks, Jennifer. So as you're responding with your name and your favorite animal in the chat, if you can make sure that is sent to all participants, as opposed to all attendees. If it's sent to all participants, everyone, including the panelists site, will see it, and that's important. Thanks so much. And Michelle, born and raised in rural Ontario, studied mathematics, physics, and education before moving to Texas. Michelle has taught high school math and science at rural districts in Texas, while also working as a math and science consultant. Her interests include technology integration, conceptual understanding, and curriculum and instruction. Thanks for being with us, Michelle.
Thanks, Mike. Glad to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to Michelle or Jennifer using the Q&A window in the right section of your screen. Once we begin with sharing our teacher software, that right section of your screen will be replaced with a green floating toolbar at the top, and you can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once the recording is made available, if you'd like to follow along with your handheld or your software, we truly hope you will. We do recommend doing that with the recording, though. That way you can pause and rewind and use the recording to go along at your own pace. We hope you don't have any audio issues tonight, but if you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Michelle is going to discuss our agenda and our expected outcomes.
Thanks, Mike. Here's our plan for this 1 hour webinar that we'll spend together. We're going to look at some building concepts in mathematics activities related to statistics. And Jennifer's going to take us through an activity where we'll be introduced to data and asking statistical questions. From there, we're going to spend time looking at how we can tell the story of a data set by looking at measures of spread and also measures of center. So we'll do that through activities about median, interquartile range, also looking at box plots, and then hopefully if we have time, moving on to some activities thinking about mean in two different ways, mean as fair share and mean as balance point. We'll also share some free online resources and have a giveaway at the end of our session tonight.
And sorry, Michelle, give me 1 second here. And in a few seconds, Michelle is going to discuss our expected outcomes right now. Sorry.
No problem. So hopefully by the conclusion of this webinar, our goals are that we'll be able to connect statistics and probability through a coherent story within and across some grade 6, 7, and 8 topics, while also leveraging TI Nspire technology to enhance visualization. It's going to be a big part of what we look at tonight is how do we begin to visualize some of these concepts that we may have previously been able to compute, but what do they look like visually and what story do they tell us? Also, we'll have some discussions about how to implement effective teaching practices to support truly developing these tough-to-teach concepts.
Thanks so much, Michelle. Jennifer, it's all yours. Jennifer, just so you know, you're muted.
Thank you. I'm very sorry about that. I was all excited about the questions, the animals that were coming through the chat. Sorry about that part. So we are going to start the night with an activity that is called Introduction to Data. We're going to brainstorm first what statistical questions we might ask based on the list of favorite animals that you've been seeing come through the chat. So we'll take just another minute just to think through what are some questions that we might ask based on this, what is your favorite animal, this list of favorite animals that we have. Okay, so I see which animal is most popular, which animal do we have the least responses? That might have been the one from the Super Bowl. So different types of animals. Which one of the animals is the fastest? Okay, so as we begin to think about what is a statistical question, we want to define a statistical question as a question where the responses are going to have variability. So the question, what is the age of my dog versus what is the age of the dogs of the people who are here on the webinar? When we think about what is the age of my dog, that is not a statistical question. The response has one single answer. But when we ask what is the age of the dogs that all of us on the webinar have, then that can become a statistical question. And we can use the data that we get from those answers to begin to summarize the answer to that question about the age of the dogs those on the webinar have. So Mike is going to start a quick poll for you. And in this quick poll, we want you to select the questions that are statistical questions. These are the 5 questions that you're going to see. Which ones of those are statistical questions? Which ones will the responses have variability? Getting some responses in.
Hey, Jennifer, can we try that one more time?
The quick poll?
Yeah.
Sure.
Maybe not. Just clear my entire poll. How about we do this? Do you have?
So it should be, yes, here's what we can do. I can share my desktop so that you can see these questions. It looks like, yeah.
I got them back. I'm sorry. We're good.
Okay. Okay, so here are those 5. So the poll is going now?
Nope.
Not
It
yet?
is right now. There we go.
Here we go. Okay, so which of those are statistical questions for which will the responses have variability?
We'll give you about our 10 seconds. And we'll show those responses in about 5 seconds. Okay.
Thanks, Mike. So, Jennifer, it looks like overall as a group, not many of us thought that question A, what is the fastest recorded speed for a human, was a statistical question. What do you think about that?
Okay. So if we're specifically talking about the fastest recorded speed for a human, then we're going to say that that has a single answer. There's not variability in that. So we would not consider that one a statistical question. What about the rest?
As a group, we also thought that question C, really, can land animals travel faster than birds, wasn't really a statistical question. What do you think about that?
So I think that this can become a hard thing to think about, but in general, are we talking land animals and birds? If we start to think about the statistics for land animals and with birds, we're actually going to look at some plots of these a little bit later, then that might actually be a statistical question because we're looking at groups of animals and the speed that they have. You would have to think about, well, how am I going to talk about the speed of land animals? Is that already just a single answer, or am I going to have some data from some certain land animals, and am I going to measure that in some certain way, talking about a specific statistic? So I think maybe
so our goal sounds like we might.
3.
Okay, so like we might end up with a yes or no answer, but we're going to have to look at variable data in order to get there and then to back that up. Okay, so then we looks like we were pretty evenly split about the other questions about B, D, and E that a large group of us kind of thought that those ones were statistical. What do you think?
Okay, so how much water does a dog drink in a day? I think we could definitely go statistical with that. That's going to depend on other factors. If we were talking about how much water does the dog drink on, February 14th, that's a different question than just in general, how much water does a dog drink in a day. How many pets do you have is an interesting question to me. I live on a farm, and we never know from one day to the next how many pets we are going to have, whether a chicken made it through the day or whether a hawk went out on that. So I think for most people, how many pets do you have is going to be a single answer to the question at this instant in time. But I think one of the things that this kind of brings up is this idea of statistical questions can be a struggle, and there can even be some, well, it depends on what you mean. When you're asking how far is it from your house to your school, well, what do you mean by that? Are you talking about on the different routes that we can go to get there, or are you literally talking about, the exact distance from the house to the school? So I think all of this is going to end up needing some conversation.
Sure, and Jennifer, some great comments in the chat I just wanted to share. Sorry for jumping in.
Oh, please do.
several of these questions were worded in a way that gave us pause and really made us think about whether they're statistical or not. And then also that several of these questions, if they were asked to us individually, may not be statistical, but if they're asked to us as a whole group, we might be getting some variability in our responses, and then they become statistical. So some great comments there.
Right. Good. I think the important thing is having some conversation about this. So we're going to analyze a little bit of data. What we have here showing right now is a whole lot of animals, and we have the maximum speed indicated for that particular animal. So I just want you to look at the dot plot for just a moment. What are some statistical questions that your learners might ask? So I have a feeling, or I can tell you from experience, that when my daughter saw this, you know, the very first thing is, oh, what's over there at that 240? You know, so one question that might be asked might be, well, which animal is the fastest? So the question, which animal is the fastest, is not going to be a statistical question here. That is, for this set of data, we have a single answer that's going to be which animal is the fastest. But examining the data to determine which animal is the fastest might lead to some statistical questions, and I think that's what you have brought up in the chat and what Michelle just noted a minute ago. Sometimes in order to answer a question, we're going to have to do some statistical analysis to get there. So the fastest animal that we have over here showing is the falcon. And we can look at some other data points here just to kind of see what we've got. Again, this is showing a lot of data. See if I can get that one off so I can show another one here. So we've got lots and lots going on with the birds that are there, and we might need to think some more about what's going on with land animals. And the way that this particular activity is set up is we can categorize the animals if we want to. All land animals, all sea animals, or all animals, or we can then even do it in some smaller categories there. But one of the other things to think about here is what are some of the talking points that you might note with your students when you look at this particular distribution. If we look at this dot plot, what might we say about that data? What might we say about the shape? So I see one thing that's coming out, one talking point might be the frequency. And yes, absolutely, we're seeing that noted in the dot plot. What are some other things that might come up just by looking at the data? Okay, so I see right skewed. So yes, we have that falcon over there. We've got a right skewed distribution. And again, this is just an introduction to data, so students might not know the you know, terminology, mean and median and range, all those kinds of things yet. We're just, you know, beginning to introduce that. But yes, this falcon is definitely pulling out the mean a bit by that. So I'm seeing some others come in talking about what can we say about the majority of the animals here, thinking about range, what might that look like. So let's think about another statistical question for just a moment. So the question is, do cats or dogs live longer? So what do you think? Tell us in the chat. Cats or dogs? Which live longer? And while you're answering what you think about that, I'm going to go on and set the plot up here. This is one of the things that you would think after teaching for as long as I have that I would have this down by now, but I really have to think about asking my students to make predictions before we go right into the math and into the analysis. And so that's one of the things that I've been working on really over the past year or two, is asking them to predict what they think is going to happen before we look more into the data. So on the top graph here, I'm going to select cats. And on the lower graph, I'm going to select the dogs. And then the attribute that we're going to choose is the lifespan. So now what do you think? Looking at those two dot plots, what would you say? Do cats or dogs live longer?
I love the comment in the chat too about how it depends on the kind of dog / cat. I thought that was really interesting.
Mm-hmm. Absolutely, and we can see that even here in the dot plot. That's the nice thing about looking at these dot plots with the same scale and one on top of the other, so that we could get into some more specifics if we wanted to there. So we could probably spend our entire night together just looking at some different plots here and thinking about statistical questions that we could ask. But we're going to move to Michelle now, and she's going to introduce us to another building concepts activity, median and interquartile range.
Wonderful. Thanks, Jennifer. So based on some of the work that we've just done, we now can ask these statistical questions, but now we're tasked with coming up with, well, how do we tell the story of the data set? How does this data set help us actually answer these statistical questions? How can we make sense of what's going on? So in this activity, we're going to look at a few ways that we can describe the distribution of a data set. So we'll start with this one. The data on this page represent the scores in a game by a group of people. So I'd like us to take a minute and with the data kind of as it is, all kind of randomly distributed, share how you would describe the distribution of these scores. Can you share some thoughts in the chat about what the largest value might be or the smallest value or any clusters you might see? What does the center of the data look like? Take a minute or two and share some thoughts about this distribution of data in the chat. I'm noticing a comment about how it kind of looks like the numbers maybe go from 28 to 37. So maybe we can try to arrange those a little bit. Perfect. So Jennifer's just kind of trying to move through and make sense of the numbers and put a bit of order or arrangement to them. Great. I see some more comments about smallest to highest. Looks like we're going from the high 20s to the mid to upper 30s. Great, and Jennifer has quite the task here of trying to organize all that and make sense of it. So moving the numbers around, as Jennifer's doing, may help us think about the distribution of these scores. So we're going to go ahead and order the scores or have the software order the scores for us. So we push the order button, and as the scores become ordered, I'd like us to think about what additional observations can we make now that the scores have been arranged or ordered. Any changes to our previous observations or any new observations to share? Okay, I like the idea of dividing kind of into quartiles, and we'll kind of move into that. Comment about now it's easier to kind of find the median and the quartiles now that they're ordered. Okay, great. Jennifer's going to help us move to another representation that'll hopefully make it even easier to analyze this data. So we'll go ahead and push the graph button twice and create a dot plot for this particular data set. And this representation of the data may allow us to describe certain characteristics of this data distribution more easily now. So for example, we might now be able to see clusters more easily or gaps in the data if we did have some of those. It might be a little bit easier to discern those details now rather than when the data was just in a list format. So one other important idea I'd like to kind of make note of here before we move on, and that's the idea of the range of this data set, which in this case appears to be 9, I believe. You can determine that by taking the maximum value, I think that's 37, and finding the difference between that and the minimum value of 28. So notice that the range, which for this data set was 9, is itself a single number and not a maximum minimum pairing. So you can use that maximum pairing to determine the range, but the range itself is a single number that is one way to represent the spread of a data set. Okay, let's go ahead and look at an additional data set. So we're going to move on to page 2.2. And this particular data set represents the scores of 17 students who were playing a game. And before we really begin to analyze, let's make a prediction again, like Jennifer was saying earlier. What do you think the middle score in this distribution would be? So we'll just predict, take a minute, share in the chat. What do you kind of predict just by glancing at the data? It would be the middle score for this distribution. Okay, so we're seeing some values between maybe 18 up to 23, somewhere kind of in that range of numbers. Looks like our middle score might be. So let's investigate. Jennifer's going to go ahead and press the mark button, which will give us a vertical marker with counters above it. And the counters represent the number of data points on either side of that marker. So Jennifer can use the left and right arrows to move the marker through the data set. You can notice how the numbers change as she moves that marker through the data set. So if our goal is to find the middle number in this data set, Jennifer would need to move the marker so that there are an equal number of data points on the left and on the right sides of the marker. So it looks like that's going to happen right about here. So here's where that happened. The 9th score in this distribution, which has a value of 22, has 8 scores below it and 8 scores above it, so it is the middle score. This page, like the others we have looked at, is dynamic in nature. So we can grab the points in the dot plot and move them around to see how they affect the median. So we'll kind of model that a little bit. And while Jennifer's modeling that, this would be a great place to ask kids some questions that they could then explore and try to make sense of what's happening with these data sets. So some statements we could explore to determine the truth value of might be, when the number of scores is odd, the median will be one of the scores. Is that always true? Or we could explore, when the number of scores is even, the median will not be one of the scores. Is that always true? So the dynamic nature of these documents allows students to really dig in and investigate some of those interesting concepts. Okay, let's look at a new set of data. So Jennifer, if you'll press New Data, again, we'll select Mark and then move our marker along the data set in order to determine the median or middle value of this data set. So there we go. Once we have found that value, let's go ahead and press Mark again. So what's going on here? This new mark will help us find the median of the lower half of the scores. This value, in this case, the value is 8, is called the lower quartile. And this value separates the lower quarter of the data from the upper 3/4 of the data, or 3/4 of the scores. We can select Mark again, and then use similar thinking to determine the median of the upper half of the scores. So this value, in this case, 30, is called the upper quartile. It separates the upper quarter of the data from the lower 3/4 of the data. And now with our lower quartile and our upper quartile marked, we can determine the interquartile range of this data by finding the difference between the upper quartile and the lower quartile. So in this case, the IQR would be 22, or would have a value of 22. And this is another way that we can think about and describe the spread of this particular data set. So here we've built some understanding of how we can describe the center and the spread of data sets based on the ordering and relative position of the values in a data set. So the median represents a measure of center here, while the range and interquartile range describe the spread of the data. So kind of cycling back to some of the questions that Jennifer asked earlier, those statistical questions, and then our attempts to tell the story of that data. When we're telling the story of a data set, it's really important to consider the measure of center and the measure of spread. Jennifer is now going to walk us through another way to view this data story.
So the work that we just did with Michelle on median and interquartile range leads right into ultimately summarizing the data with that 5-number summary or box plot as we know it. So the data at which we're looking right now is the number of text messages sent or received in a day by a 12 or 13-year-old who took the survey. For example, right here we have a 12 or 13-year-old who sent about 40 text messages, sent or received about 40 text messages per day. And then we can see up here that we have a student who received or sent about 140 text messages per day. I decided that they did not survey my 13-year-old daughter, Jane, as she would be an outlier on this dot plot, not even seen in what we see right now. I want you to estimate the median and the interquartile range. A minute ago, Michelle had us just look at the dot plot and give an estimate of what the median was. So let's add to that, what would the interquartile range be as well? So I'm going to take just a minute for you to just look at the data and see what you think. Median and interquartile range. Okay, so I think we're seeing something about 70 to 80-ish for the median, maybe 65-ish. And that interquartile range, as Stacy just noted, is, again, the actual statistic, the number that is the quartile 3 minus quartile 1. So that number that represents that. So here we can actually mark the median. So the median here is actually 44. And then we also see the interquartile range, which is 68. Now, one of the other things, before we look at the summary here, what would you say about this distribution? We talked before when we saw the speed of all of the animals, the maximum speed of all the animals. We've noted that that was skewed right. We had the falcon who was pulling out that tail to the right, pulling out what we already know of as the mean. So what would you say about this distribution with the text messages? Okay, so I'm seeing some terminology here. We've got cluster, and we have really a tail that's over here to the right. And so we can see that about half of the students are sending or receiving more than 44 text messages. We can see that about half of the students are sending or receiving less than 44 text messages. So we're going to look at what happens when we summarize this data. Now, many of us know the box plot as the 5-number summary. And so what we see here are the two extreme values. We're seeing the minimum value represented in the box plot. We're seeing the maximum value represented in the box plot. We have a box that is drawn around the interquartile range. And so here we see that lower quartile and the upper quartile, and then we have a vertical segment here that's drawn at the median. And so as we hover over these different quartiles, not only do we know that each quartile represents about 25% of the students, we can also see with the specific data points that we have about the same number of data points in each one of those quartiles. So I think that's a really nice thing for students to see, because there's definitely that misconception that we have more data points represented in a part of the box plot that is longer, and so we want to make sure that that misconception is cleared up. So I think the data points very nicely note that. You might have noticed my language here saying that we have about 25%, we have about the same number of data points in each one of those, and that's just, you probably know that there are actually a few different ways you can think about calculating quartile 1. Some textbooks include the median as part of the lower 50% to calculate Q1, and some of them don't include the median, and so I'm just saying about for that reason. How it's calculated here is noted in the teacher notes. So we talked about kind of what the box plot represents here. And so one of the things that we could say about the data that's represented inside the box is that we have about 50% of the students represented inside of the box. So we have about half of the data in that interquartile range. There are lots of pages that go along with this box plot activity. We're just going to look at one more. And so what happens on page 4.2 is that this page provides the opportunity to compare box plots. The two box plots that we see now show the girls' and the boys' responses to the survey about the number of text messages sent or received per day. So take just a minute to examine those two box plots. What are some key differences that you note between the responses of boys and girls? What would your students notice and note when they saw these two box plots compared? Okay, so we've got some in general. The girls send more than the boys. There's a bigger range in the girls' data. So what about this minimum value for the boys? What does that tell us about the data for the boys? And so we can begin to think about, what does it mean to have 0 there as the minimum? Does that tell us that there are a lot of boys who send and receive 0 text messages? Does that tell us that there is 1? Does it tell us that there is at least 1 boy who sends and receives 0 text messages per day? So beginning to think about, what do these numbers mean in terms of the data, because we're not seeing specifically the dot plots from just the boys and just the girls. And yes, so we know with that 0 that we have at least 1 boy who sends 0. There might be more, there might not, but we have at least 1. Just like we have at least 1 girl who sends and receives 240 text messages. Okay, another nice thing about this data is, we can go from the point of view of asking our students to look at the box plots and tell us what they can tell us about differences between girls and boys. And actually, one other talking point that we might want to note is, are there more girls represented in this quartile than there are boys? Can we figure that out from just looking at these box plots? We really don't know how many girls were surveyed and how many boys were surveyed. So we know that this quartile 2 right here represents 25% of the girls, but we don't know what number of students that actually is. But the other nice thing about this is that we can go backwards with the questions that we ask. These points are movable, and so we could ask students to rearrange the data so that 3/4 of the boys send or receive more text messages than 1/4 of the girls. So I'm going to say that one more time so you can kind of think about what that would look like. What would the box plot have to look like if 3/4 of the boys send or receive more text messages than 1/4 of the girls? So we want 3/4 of the boys to be above 1/4 of the girls. So this would just be one way that I could represent that statement, that I could make that statement true now from looking at these two box plots. So I think that's a really nice addition to this. Let's say a statement we want to be true, and now you rearrange the data so that it is. And if you had TI Nspire Navigator with your students, then you could capture the different screens of the students, and you could look at how they have changed that data altogether. So we could, again, do a lot more comparing data sets using box plots, but we're going to stop here for now, and Michelle is going to share with us how to find these activities on the TI website.
Thanks, Jennifer. Just lots of things that I was thinking about just from those demonstrations that you were sharing about how, box plots help us. They're such a powerful tool to help us analyze data. When we were just predicting the median and the interquartile range from just the dot plot, it was really hard for us to be accurate, even though we knew kind of what we were looking for. So those box plots really give us added insight into what's going on with that data story. That's neat. Okay, so we're going to go check out the TI website and find where you can access these particular free resources. There's a ton of other free resources on the site as well. For today, we're going to start by navigating to education.ti.com, and from there, we'll go to the Activities tab and then the Building Concepts in Mathematics option, as Jennifer is showing us. So this will take you to the Building Concepts in Mathematics kind of landing page, if you will, for all of the Building Concepts progressions of activities. So there are standards-aligned activities here that develop ideas in fractions, other activities that develop ideas in ratios and proportional relationships, some for expressions and equations, and then also our focus for tonight, statistics and probability. So when we click on the statistics and probability option, we will see the sequence of 5 activities that we have been sharing with y'all tonight. Clicking on any particular activity, so let's say Mina's Fair Share, which Jennifer will highlight next, brings up all of the resources for this particular activity. So if you scroll down a little bit, here we will find an overview video, as well as detailed teacher notes, student activities, and the TNS files for use on your TI Nspire handhelds or software or iPad apps, however you're using the TI Nspire platform. So this is the next activity that we're going to check out, but we wanted to share with y'all where these activities are, and they're already posted live and ready for use with your students and learners.
Hey, Michelle. Hey, Michelle.
Yes, sir.
Sorry, before we leave that page, I think that you and Jennifer are both involved in writing material for the Building Concepts workshop that's, I believe, currently being offered. I was wondering if you could just talk for a minute about that. I put a link in the chat window for anyone that's looking for more information.
Wonderful. Yeah, I'd love to. So yes, Jennifer and I have both been involved with writing some workshops that go along with these activities. Started with ratios and proportionality, and both Jennifer and I were able to pilot those professional development sessions. And I cannot even begin to tell you how much I've learned about ratios and proportionality from those particular sessions. Really, it's an opportunity to dig deep into these concepts and to dig deep into the visualization of these concepts and to think about really critical student misconceptions and also ways to develop the conceptual understanding of these topics that will then lead into procedural fluency as well. So Jennifer, anything to add about the specific PD sessions?
The only thing I'll say about the PD is that, wow, what a learning experience it has been for me. We did the ratio and proportions this past summer with some of our middle school teachers, and the community that we built of learning during that time together was really powerful. Really struggling with, how we define these terms and what they mean and what does that look like in the context of problems. And so we really have learned a lot for ourselves as well as for our students.
Thanks so much.
All right. So we're going to look for just a minute at mean as fair share. And so I think I'm going to go right into the activity here because I want to make sure we get to mean as balance point. And so one of the things that comes out in mean as fair share is we're just kind of developing this idea of mean, is that we begin to think about more than one way to give a fair share to whatever it is the context is. Here we have the context of dogs and bags of food, and so we want to distribute fairly these 8 bags of dog food to the 3 dogs that we have. And right now we can see that the distribution is not fair, and so we can do something about that. We might give this dog on top 1 bag from the middle dog and 1 bag from the dog on the bottom, and we can still see that that's not completely fair. But if this dog gives this bag up here, then it's not fair to the middle dog, right? So maybe we need to take this bag and we need to split the bag. And so if we were to split that bag into 2 parts, then we still don't have equality here, right? Because these 2 have 2.5 each, but this 3rd dog down here has half. And so we're going to have to split that bag so that each one can get part of that, and split this bag so that they can each get the same amount of those bags, and then we're going to have to take this bag and also split it into 3s so that that can be distributed equally. And so now we can see that we have these equal parts of the bag for all 3. So with those 8 bags, each one ends up having 2 2/3 of a bag. I'm going to move on to another page of this, and we're going to take the same number of dogs, and we're going to take the same number of bags, but we're going to look at distribution a little bit differently this time. Instead of that idea of kind of a give and take so that we end up all with the same amount, here we are going to total the 8 bags, and then we're going to do the fair share. And then we'll have to split and share these last 2 bags. So again, we're not to the point yet where we're saying you need to add up how many you have and divide by the number to get to the mean of the data set. We're really trying to develop that understanding conceptually of what a mean is. And then one thing else to notice here is that this file is called mean as fair share. In a minute, Michelle's going to talk about mean as balance point, and the emphasis really is on the word mean as opposed to using the word average. Mean is purposely chosen throughout the building concepts activities, and that's based on the learning progression document, since average has many non-mathematical meanings. So this moves into what is this going to look like if we have, I'm going reset this so we don't have an equal number. Let's try one more time. Divisible again. Do it one more time. There we go. Okay, and so again, that idea of combining the bags and thinking about where they need to go and what do those look like there on the dot plot that we have, and what is it going to look like once we get a fair share? What will that dot plot look like? I have to do both of those into thirds, and then we can give a fair share. Instead of thinking about what does the mean look like when everybody has a fair share, what will that dot plot look like? So that was a very quick introduction to that activity, but with a little bit more time, those ideas will lay the foundation for the mean as the balance point. And so I want to turn that back over to Michelle so she can at least give us just a taste of this, and then maybe on another webinar we can get into more detail with mean as balance point.
So I love how the dot plot that you just finished with, where we had the 3 values and the puppies each had, I'm not sure the exact number, if it was 2 2/3 bags after doing the fair share. That dot plot looks very similar to this dot plot. So here we're actually looking at the results of, say, a soccer tournament. And these are 9 different teams, and what is being plotted is how many goals they scored throughout the tournament. And it was a round-robin tournament where they all played the same number of games. So here we're seeing that the total goals were actually fairly shared, if you will, between the different teams. This is also a dynamic file, so Jennifer can go in and actually change the results and move some teams around to represent perhaps a different round-robin tournament where some teams scored more goals than others, but maybe we keep the total number of goals the same. So when we first started, we had 54 total goals, and we might make another change or two and still have 54 goals total. So let Jennifer kind of make some changes there. So now we can kind of ask some questions about how this tournament compares to the tournament that we were just seeing a minute ago. Is this tournament a fair tournament, if you will? What does a fair tournament mean, and how do we compare or rank different tournaments in terms of their fairness? So Jennifer, let's go and take a look at that slide with some different sample tournaments for us to kind of consider. And I'd like us to kind of consider for a minute the 4 tournaments that Jennifer is going to bring up. And in each of these 4 tournaments, there were a total of 54 goals scored combined between all of the teams. And I'd like us to kind of think about and posit, how would we rank these tournaments in order from the most evenly matched to the least evenly matched? So take a minute and share an idea in the chat. How would you order these tournaments from this is the most evenly matched to the least evenly matched? And again, we're kind of just making some predictions based on dot plots. We know there are some other statistics we can look at as well that will help us really make sense of this, but the dot plots give us an initial view of kind of what's going on with that data. Wonderful. See lots of predictions coming in there. So I think it looks like we all kind of agree on the fact that C looks like the least evenly matched tournament. We've maybe all been in one of those before, perhaps on the losing end, not so fun. But the others, A, B, and D, it's kind of hard to tell based on just these representations. So we're going to consider just 2 cases, kind of narrow down. And let's consider just just tournaments A and B. And so Jennifer will give us another slide where we have this kind of large scale. In the last few minutes we had together, I'll give you just a little bit more information about this. We had 9 teams in each tournament, a total of 54 goals. So if we think of that idea that Jennifer modeled about combining all of the goals, dividing them up between the teams to determine what the mean of either of these tournaments would be, the mean would be 6 in both cases. And yet we need a way to figure out which tournament was more evenly matched, even though they had the same mean. So this kind of cycles back to the idea we've been building towards all night about how when you're telling the story of the data, you have to consider the measure of center, in this case mean, which is identical in both tournaments, but also this idea about measure of spread and how that affects the situation. So this is a great activity that then segues into how could we actually put some numerical values on this and quantify this idea about these tournaments being evenly matched. So think about that for just a minute. How could we actually quantify or come up with a numerical way to compare these two distributions? We know the mean in both cases is 6. How could we actually quantify the spread here? So take a minute or two and share just kind of some initial musings in the chat, and then we'll pull together some of those ideas. So some interesting ideas on this, and this is definitely a challenging task when we're first thinking about it. We might have some inklings about which of these we feel is more evenly matched, but actually being able to quantify it and overlay some numbers on that is difficult. So we could begin with the idea, someone shared in the chat, about looking at how many deviations there are, how many above and below the mean the different teams kind of sum to, so kind of distance from the mean or total distance from the mean if we're summing all the points. So this will develop an idea called the sum of the absolute deviations, sometimes abbreviated to SAD. And then later in this activity, we develop all the way to mean absolute deviation, as someone shared in the chat as well, which will help us make sense of and compare two data sets when they don't have the same number of teams. So say a tournament where there were 12 teams versus a tournament where there was 9 teams, how could we then consider and describe the distribution? So just a sample of another activity that kind of helps us tell the story of a data set by comparing, by describing and analyzing measures of center and also measures of spread. Jennifer, anything else to add about those ideas as we kind of wrap up for the evening?
I think that is all for now. I think Mike is going to fire us if we don't give it back to him. We have so much to talk about, though. We'll have to have another webinar soon, or maybe we'll see some of you at the International Conference in Orlando in a few weeks, and we'll definitely be talking about these building concept activities there.
Great segue. Thanks so much, Jennifer and Michelle. As Jennifer mentioned, we do have an international conference coming up in a couple weeks, so we really do hope to see you there. Michelle mentioned earlier that tonight we're giving away 2 free conference registrations to 1 lucky winner, and tonight's lucky winner is Jackie Holman. Jackie will be in touch via email in a couple days, but congratulations, and we hope to see everyone there in a couple weeks. When you leave the webinar, a brief survey will appear in your browser window. Your feedback is important to us. We do read and listen to all your comments and try to make any changes or suggestions based on the needs of the group. So please feel free to share your thoughts in the post-webinar survey. Both Michelle and Jennifer are on Twitter, I know for sure. If you like some of the things you saw tonight, please feel free to reach out and continue the conversation on any of the social media outlets. To receive a certificate of attendance, please click the link in the chat window. That link will give you the certificate of attendance, and also a link to the documents which were used tonight by Michelle and Jennifer. If you have to miss it, just check your email in a couple days. You'll automatically get a follow-up email from us, which will have a link to the certificate, the documents, and a link to the recording as well. If you have to be one of our on-demand listeners, go ahead and copy that link down and just paste that into your browser window. Tonight you guys were great with any of your comments and questions in the chat window and Q&A. In case there are any questions that weren't answered, please feel free to reach out to us by either giving us a call or sending us an email. Awesome job, Jennifer and Michelle. Thanks so much. I really do enjoy seeing these building concepts material webinars just because I think that they really bring me back to some of my roots and make me really think, like Jennifer and Michelle, you both said about the ratios and proportions. I really thought I knew ratios and proportions, and then I started looking at some of the material and realized that maybe I need to look at it again. So thanks so much for sharing everything tonight. We really appreciate it.
Thanks, Mike. Thank you all for being here.
Yeah, we enjoyed it, and thanks for participating in the chat with us. We really appreciate that.
Thanks so much. We hope to see everyone back online next week. Thanks again.